following on from our previous Python for data visualization tutorial where we covered Matplotlib, Seaborn and pandas. We're going to delve further into Matplotlib and Seaborn for practical visualizations and how to best utilize these libraries for data science. These are the categories we're going to cover, everything from the imports, line plots, customization, bar plots, histograms and so forth. The similar things with Seaborn, but also looking into disk plots, KDE plots, box plots, heat maps and more. At the end of this tutorial, you'll be able to replicate these same plots using the basic strategies and core code that we've implemented throughout the video. First up, the imports. You'll need to import these libraries to be able to use them. Now in this tutorial, I'll be using the Jupyter Notebook environment, which I highly recommend you install. If you don't have this, feel free to use Google Colab. You'll have the same online yet collaborative environment stored within your Google Drive. When importing Matplotlib, you need to type import matplotlib.pyplot as PLT. PLT is how we'll reference the library going forwards in our plotting, and you'll see that in our next demonstration. Then we'll import Seaborn as SNS. Why these names? Convention. This is what people will understand when reviewing your code, and they'll make the most sense if you're using snippets from others' codes. Matplotlib. Let's create the data points we're going to use for this plotting. You'll see here I've created two lists stored within the variable of number of customers and years. Each of these contains 6 elements, which I intend to correlate the number of customers over the years. Now just by looking at this you can see that in 2010, the first element in this series had 1 customer, whereas 2015 had 6. Looking at this is helpful, but what if I wanted to plot that with our first line plot? We'll reference Matplotlib with PLT, as you saw before. Then .plot as a default plot is a line plot, and we'll pass in these 2 elements, these variables of number of customers against years. Let's run that. And here you go. You can see how over time it grows. But let's add some detail. There's no title or axis labels. First we need to plot the same graph, so I'll do that again quickly with plt.plot. You'll see here on the y-axis we have the number of customers over years on the x-axis. So how do we plot this? Well, it's actually very simple. It all starts with plt dot followed by what label you want to add. We'll start with the x. Then plt.y label. Finally, we'll add the title with plt.title. And hit run. And as simple as that, you've labelled the axis and given the chart a title, giving it just that much more detail. But what if we had 2 data sets and we wanted to compare them both in the same graph? Well, I've created this and let's pass it through here. Taking a look at this, you'll see I'll have the variable of Jerry's customers, Toby's and years. Again, they both have 6 core elements being a number of customers across the same years. Now how would we plot it? We'll actually do it in the very same way as before. So let's go up here and copy this. Now as you can see I've written this out in the very same way as before with plt.plot years versus customers. But I've written it for both people, both variables. I've then labelled the axis and given it a title. And you'll note if I hit run within this cell, it'll appear on the same graph. It is difficult to see, however, which colour corresponds to which person. So we're going to add a legend. I'd also like to change the size of this graph and customize it, which we'll focus on shortly. But let's start with a legend. So again, it's very simple. You can probably spot the trend by now. It's just plt.legend. Pass in the brackets. But within this, we'll also put square brackets. The first one was Jerry's, so we'll title that. Followed by Toby's. And we'll hit enter. You can see the orange corresponds to Toby, which we can confirm because we can see at its highest point in 2015 it's 12, which in Toby's highest point in 2015 it was 12. Just make sure you put it in the right order. Next we'll adjust the figure size. We want it to be slightly bigger. Again, it all starts with plt.figure, and we want fig size to equal, we'll put 12 by 6. And there you go. Again, feel free to play around with the different sizes. Next, let's customize. We'll do years by number of customers as before. Except this time, I'll put the marker as X. The line style is dashed. And the color as red. And as simple as that, we've customized our plot. Here, I'll throw in some data and run it. But let's plot this as a bar plot. Well, rather than simply typing plt.plot, giving you the default line graph, we'll specify we want plt.bar. And we're going to plot person by sales. As simple as that. By changing what you put after the PLT, this will change the style of graph, as you'll note going forwards. But what if you wanted a stack bar? Well, this becomes somewhat more complex. Not entirely, but I'll throw in something and then I'll explain it. You'll see here we have data on apples, oranges, and again, which we're plotting this on year. Initially, we just want the plot for years and apples, followed by oranges. So you plot this separately. But you put on bottom in the second bar chart, apples. When we hit run, you'll note this equates to apples, which we can again confirm by looking at the data. Next, a pie chart. Again, this is getting progressively complex, but soon we'll be over at Seaborn, and we'll see a lot of in-depth examples which you'll enjoy. There's several ways to complete this, but we'll look at the dictionary method as my personal favourite. If you're unsure on some of these key terms or what a dictionary is, look back to my first video on the basics of Python to get a better understanding. Here you'll see in this dictionary, stored under the variable data, Toby's equates to 20, Jerry 10 and Amy 40. And this plt.py plots the values against the data keys. Let's hit enter. And there you go. I tend not to produce pie charts, and actually a lot of people would advise not presenting them at all because they can become quite complex when you have loads of data points. But it is interesting to see that it's possible. Next, histograms. Let's pass in some data and then create the histogram. Can you guess how this might be? Well, if you guess plt.hist, you'd be right. We'll have 10 bins, but I'll show you how you can change this and what effect it has. Now, it does become quite difficult to differentiate the different columns. But before I get into how to do that, let's add more bins. Let's add 30. And you can see it really changes the look of your graph. Let's add 5. Very different. So we'll stick with 10. Bins in a histogram are intervals that group the data, and choice of bin size will affect how the distribution is displayed. Back to that edge color. Well, it's just edge color. We'll go with black. Run it, and it's a lot easier to differentiate. What if you wanted that customization, that title and axis labels? Well, if I paste this in, it's the same as before. plt.title, x label, and y label. Penultimately, the box plot. Let's pass in some data ranging from 10 to 70. And very simply, it's plt.boxplot and passing in the data. Let me show you. And again, feel free to customize this as you see fit. Finally, a scatter plot, and I've passed in some data for the x and y axis. Now, if we want to compare these two numerical values, a scatter plot would be brilliant for this. And very simply, it's just plt.scatter. X versus y. And there you go. Again, you can make all the same titles and labels as you so see fit and make all the color customization. You'll see here, I've added a line through the plot in this double line style. I've also added a title and made the color red. And as simple as that. you drastically change the look of your visualization. All of these core principles are the same throughout all the different plot styles. It's just what do you put in when you're passing it through and what you put off the PLT which change. But always remember, it starts with a PLT. As an extra note, if you did want to save this, you would just run this command. Again, plt.savefig, and then what you'd like to call it and the file type you'd like to save it as. And this will save it directly into your file. Next, Seaborn, my personal favourite visualization library for the typical day-to-day use case scenario. Let's start with our imports. Now you can import custom datasets, let's say df being the variable name equals pd.read_csv and the name of the file. Of course, for this you'd have to use pandas, so make sure to. What we will do is use Seaborn's built-in libraries. We're printing out, as a list, all the names of the datasets stored within Seaborn, which we've titled SNS. So print SNS dot, always the name of the library, followed by a dot, get underscore dataset underscore names, and then followed by these two brackets. What we'll do here is some data exploration, and we'll go through the tips dataset here. We'll call the data tips underscore data frame
equals Seaborn.
If we look at this dataset, say the top 3 columns with tips.head, and here we go. You can see the top 3 columns of this dataset, covering total bill, tip, sex, smoker, day, time, and size. It's always good to explore your data and get a better understanding. We can do this with the .describe and .info methods. This will give you some statistical understanding of the data, whereas .info will give you the columns and the data types and whether there are any null values within those variables. But let's get to visualizing. Bar plots. You'll see this is used for focusing on distributions using categorical data in reference to one of the numerical columns, such as day by price or total bill. Again, this is very simple, and you can probably guess it starts with sns.barplot, as that's the visualization we want. Passing the x, here we'll use day, and y as total bill. How do I know these titles? Well, again, it's by looking here in the dataset. But if we just run this, it won't work, because we do need to specify which data we're looking at, and here it is the tip df. And here we go. You can see it's automatically given it labeling. But what if we did want to give it a different label and or a title? Well, we go back to our trusted Matplotlib library. You can use Matplotlib to influence the Seaborn visualizations and plots that you create. And that's how they interlink together. And how typically I like to use Seaborn, with just the hint of Matplotlib. Next, a count plot. Now this is similar to a bar plot, but the estimator is counting the number of occurrences rather than referencing it to something else. So here, as per before, we'll do sns.countplot, hitting tab to autocomplete. X will do sex, data being tips df, and we'll run that. And here you go. 2 very similar visualizations, but with different core principles. One comparing 2 values, numerical and categorical, and one just counting the number of occurrences in a categorical dataset. With scatter plots, it's all the same, sns.scatter. And it'll look just like this. You don't always have to use a pre-built-in dataset, as within Matplotlib examples where we used our own data we hand-typed in. Let me paste in another example. Here's the sample data for x and y. Now here we'll create the plot. Rather than specifying the data, we just pass in those variables of x is equal to x and y is equal to y. And then you can customize this if you so choose to. And it'll work all the same. With a histogram, this is referred to as a hist plot, and is all similar. It's probably getting very repetitive now, which is good. It means you're understanding the fundamentals of how this works. It'll start with sns.pisplot. We'll use the data as tips, and you could put that at the end or the beginning, it doesn't particularly matter. We'll use x as total bill, and we'll put KDE as true. We'll hit enter. And there you go. If you didn't want that line, well, you'd put it as false. It works all the same. Here's another example with a bimodal distribution from another data set. We've got the penguins data set, and within this I found a column called flipper length. We've put the KD as false 20 bins as before, but we've just plotted the data from this data set. Now what if you just wanted the KDE? And we'll choose the column alcohol, but just the KDE. And for that it's sns.kdeplot. We'll keep exploring this dataset for the car crashes in the following displot. Now for this, let's take a look at some of those columns. So what do we call it? Crash df, crash_df.head. Let's look at not distracted. So sns.displot, the crash data frame, the not distracted column within the crash data frame. You can see here we've done it slightly differently to previously. Same here with the KDE plot. Rather than x equals, we've just put it within square brackets. The name of the data frame, we didn't specifically specify that, we just passed it through. Then within square brackets, the specific column, and same as before, KDE and bins. You'll see now we're very close to the end with just 5 more plots. Another very simple one, no square brackets needed to pass through than this, it's just sns.boxplot. We'll do this as x equals day and y equals total bill. Again, we can always add our title. You'll see here we've added a hue. This adds something to compare each variable on, and we've chosen sex. When we run that, you'll note that we have the legend. If we want to move it, we'll change the location of it with lock equals 0. That's the default, but if we want 1, that's equally okay. I'll go through very quickly on this one. It's again just sns.scatter.
Passing the variables. At the data type, x, y, and again, we'll have a hue.
Here, you can see we've got the x, y, and the hue being day. If we take out that hue, it doesn't compare each point based on what day it is, so we'll keep that in. Now heat maps. I'm going to move over to an example that I've set up previously. You'll see heat maps are a way to visualize data in a matrix-like format, meaning the data is organized in rows and columns. Here we'll use the Titanic dataset with Titanic equals sns.load Titanic data. Very simply, we'll do sns.heatmap, as you probably guessed, titanic.core, cmap equals cool warm, that's the color mode, and we'll give it a title. But let's give another example. We'll need to import numpy. We'll create a random 5x5 grid of data, and we'll create the heat map using Seaborn's heatmap function, except this time we'll just put data is data. Anot equals true adds these values in, and line width as well adds these gaps. Let's look at one more example. Again, we have pandas here, because what if your data wasn't in a matrix format? Remember, it has to be in rows and columns. So if it's not, you'll have to reshape it. Let's create an example of something that's not, with the columns x, y, and value as the pandas data frame named data. We'll convert this into a matrix-like format using pivots, similar to an Excel pivot table. X and Y against value. And then we'll create the heat map. Now this is something I recommend you look into further, as it can be considered quite complex and is one of the harder visualizations within Seaborn. For these final few, and just to speed up this process, I have already typed these out for you, which should make it easier to understand. It's all very similar as before, with loading the dataset, creating the plot starting with the name and referencing that name, dot the type of plot you want, passing in the data, the X and Y labels, and then customizing it. This here being a joint plot. Now, a joint plot is a special type of Python plot which combines multiple plots, such as scatter plots and histograms, to show the relationship between two variables. Now, by default, it's this scatter. We could also try a regression line by changing the joint plot to have kind reg. Everything else is the same, but you'll note we now have a line. What if you wanted the kind as hex? Well, you put kind equals hex. This is one I very much enjoy because it shows the density of each point based on the colour. Pair plots, however, and this is the final plot we'll cover, another very useful one that allows you to plot the relationships across the entire data frame for all numerical values. And it's very simple, probably the most simple one to plot, whilst also looking very impressive. It's just SNS Seaborn dot pair plot tips, looking at the tips data frame. And here you go. You can compare total bill to total bill, size to total bill, tips to tips, so on. You can compare everything to itself and everything else. And that concludes this short and quick Seaborn and Matplotlib tutorial. Best of luck.